let's talk about AI security. It's a topic that honestly feels incredibly complex, maybe even a little chaotic, right? With all these new threats and technologies popping up all the time, you gotta wonder, how do we even begin to build a defense? So let's break it all down and map out what a modern, effective AI security program actually looks like.
This quote from Ankita Gupta over at Octo just hits the nail on the head. The old playbooks, the security checklists we've all leaned on for years, yeah, they just don't cut it anymore. The entire game has changed, and that means we need a whole new strategy.
And here's the real heart of the problem. The 2026 International AI Safety Report calls it an evidence dilemma. And what that means is the technology is moving at light speed, but our understanding of the risks and how to actually fix them is lagging way, way behind. That huge gap makes it almost impossible to build safeguards that'll actually last. So just to give you a sense of the scale here, that AI safety report breaks the risks down into three big buckets. First, you've got malicious use. This is the stuff you see in the headlines, like AI-powered scams or deepfake attacks. Then there are malfunctions, which is when the AI just kind of breaks. It might give out terrible advice or accidentally leak private data. And finally, you have the huge systemic risks. These are the slower, broader societal impacts on things like jobs and how we trust information. The attack surface is absolutely massive.
Okay, so faced with all this chaos, we need an anchor. We need some kind of foundational model to cut through all that noise and give us a smart, structured way to think about the problem.
And that's the million-dollar question, isn't it? With so many threats and all of them changing constantly, where do you possibly start? Well, the good news is we don't have to completely reinvent the wheel. We can actually start with a classic, time-tested security principle. And here it is. This is our foundation, and it comes from the work of the Japan's Cybersecurity Innovation Committee, or JCIC. It's that classic risk equation: risk equals threats times vulnerabilities times assets. It's so simple, but it's an incredibly powerful way to frame literally any security problem. Now, this is the big aha moment from that JCIC paper. AI isn't just another asset we have to protect. Nope, it's a multiplier. It adds this whole new plus AI dimension to every single part of that equation. It's creating brand new threats, introducing completely new kinds of vulnerabilities, and it's even changing what we consider our most valuable assets. So how in the world do we build a defense for this new plus AI reality? Well, we can't just start buying a bunch of tools and hope for the best. We need a structured approach. So we're going to build it in layers, just like a modern tech stack. And we're going to start at the very top with layer 1, the governance backbone. This is all about strategy, who owns the risk, and what's our organization's philosophy on AI safety. And at this governance layer, two frameworks have really become the gold standard. First up, you've got the AI Risk Management Framework from NIST. That's the U.S. National Institute of Standards and Technology. Think of this as the high-level C-suite blueprint for managing risk across the whole company. Then you've got the AI Controls Matrix from the Cloud Security Alliance, which takes that big-picture blueprint and helps you translate it into the specific, concrete controls your teams will actually build. So why do teams gravitate toward the NIST framework? Because it creates that clean program backbone. It's like the one language that gets everyone, from your legal team to security to product, all on the same page. It takes AI security from being just some niche tech problem and elevates it to what it is, a core risk for the entire business. But look, NIST is intentionally high level. It tells you what to worry about, not how to fix it. And that's where the CSA ICM is just brilliant. It bridges that gap perfectly. It helps you answer the most practical question of all. Okay, that's great, but what controls do we actually need to go build right now? It makes your governance totally actionable. All right, so our governance backbone is in place. We have a strategy, but a strategy is kind of useless if you don't know what you're up against, right? And that brings us to layer 2, mapping the threats. This is where we shift from high-level policy to understanding the specific ways our AI systems can be attacked. When it comes to threat modeling, we've got this amazing toolkit of frameworks that all offer a different lens. If you want to get inside an attacker's head, you've got MITRE Atlas. For a super broad, almost academic view of everything that could possibly go wrong, there's this Cisco taxonomy. But for the most practical, hands-on, in-the-weeds stuff that developers are dealing with every day, the go-to is, without a doubt, the OWASP Top 10 for large language models. Let's just zero in on OWASP for a second.
This is a list built by the security community, and it tracks the most critical, real-world vulnerabilities that pop up when you're actually trying to ship an app powered by an LLM. We're talking about things like prompt injection, where an attacker basically hijacks the model, or sensitive data leakage. This is the real deal. And this is where it all connects. These vulnerabilities, they aren't just theoretical problems in a lab. As that AI safety report showed us, these are the exact attack vectors that lead to real-world harm. They are the technical root cause behind AI-generated fraud, sophisticated scams, and the creation of horrible content like non-consensual deepfakes. So we've got our governance and we understand the threats. Now for the fun part, the really practical layer. Layer 3, building the controls. This is where the rubber finally meets the road. And down here at the implementation layer, we have two absolute powerhouses guiding the engineering work. From Databricks, we get a super practical playbook for locking down the entire pipeline from the moment data comes in to the model running in production. And then complementing that, you have Google's SAFE, their secure AI framework, which gives you the high-level, secure-by-design philosophy that should guide every single decision your team makes.
What makes the Databricks framework so valuable is that it finally gets you out of framework talk and into concrete action. It helps engineering teams do a really practical gap analysis, asking, what are we missing? And it gets everyone aligned on exactly what needs to be built right now.
And Google's SAFE is the perfect partner to this. See, it isn't another checklist. It's more like an operating philosophy. It's built on 6 core principles designed to drive a real cultural shift, to get your teams thinking proactively, and to bake security in from day one, not tack it on at the end.
Okay, I know we've thrown a lot of different frameworks at you, but the real magic here isn't in picking just one of them. It's about understanding how they all fit together to form one single, coherent security system.
So let's build the whole stack. At the very foundation, we have Google's SIIF, creating that culture of secure by design. On top of that, we build our first pillar, threats, where we use MITRE, OWASP, and Cisco to understand what's coming at us. Our next pillar is controls, built with the practical guidance from CSA and Databricks to patch our vulnerabilities. And then, holding the entire thing together like a roof is our governance layer, which we define with the NIST framework, making sure the whole program is managed as a core business risk.
And this is the most important takeaway of all. These frameworks aren't redundant. They're interdependent. They need each other. A layered approach is the only way this works. Why? Because governance without any real technical controls is just expensive paperwork sitting on a shelf. And a long list of controls without a clear threat model, well, that's just checkbox security. It looks good on paper, but it won't stop a real attacker. Which leaves us with this final, really powerful thought. As this whole AI world keeps evolving at a blistering pace, the winners aren't going to be the teams with the most tools. The winners will be the teams that can learn and adapt the fastest. So the real question you have to ask is, how are you building a security system that's designed from the ground up for constant change?